Now, 3 British scientists have been chosen for this year's Nobel Prize in Physics. They are David Toules, Duncan Haldane and Michael Kosterlitz. They discovered that matter can exist in strange or exotic states instead of just remaining as solid, liquid or gas. Let's get more on this and speak to our science reporter, Sourav Roy, to explain all this to us. Sourav, tell us a bit more about these 3 winners. What exactly is it that they have discovered and how is it going to be beneficial to anybody?
Well, Malene, there are things known and things unknown, and in between are the doors that these scientists have opened. So they've opened up the doors to an exotic world where matter exists in forms unknown to us. For example, matter ordinarily remains in the form of solids, liquid or gas, sometimes as plasma. But what happens when you subject matter to extreme temperature or pressure, either too high or too low? It changes its form. And it is that form of matter which was not known to us, which we always believed that matter stayed in that form in black holes, in supernova explosions, across the universe, in dark matter. And these scientists have now opened up the mathematical as well as the physical world to quantifying that matter and to tap into its energy. So yeah, that's quite a big doorway that has been opened for us.
And how did they come up with this discovery?
Well, such a discovery has to have multiple approaches and multiple angles to it. The key approach to this discovery of figuring out how matter exists in exotic forms as condensate matter or as superconductors is through a concept of science/mathematics known as topology. Topology says that no matter what you do to matter under extreme pressure or extreme temperature, whether you stretch it or whether you crush it, its properties will remain the same. For instance, the universe. It keeps expanding, but its properties remain the same. They're universally constant. And to explain this, what topology is, let's hear as to how the Nobel Prize Committee actually explains what topology is.
It's a cinnamon bun. Here I have another thing. I have a bagel, okay? And here I have a pretzel. It's a Swedish pretzel with 2 holes in it. Now, for us, you know, these things are very different. This is sweet, this is perhaps salty, different shapes, etc. But if you are a topologist, it's only one thing that is really interesting with these things in which they differ. This thing has no hole. The bagel has 1 hole. The pretzel has 2 holes. The number of holes is what the topologist would call a topological invariant.
It's all very crystal clear now, Sourav, after that. So tell us again, exactly, for anyone just watching, a layman, perhaps not really closely following physics, how is this information going to help ordinary people in terms of day-to-day life?
At some point of time, scientists perhaps might be able to tap into this kind of matter and the energy that it holds, because we don't know how much energy it can hold. Right now, we know that energy in matter is stored in the form of electrons, protons, and neutrons. But what exactly is in this exotic form of matter? Can we tap into it? What is it that fuels the universe? 95% of the universe is dark matter that we don't know of, and yet there are black holes that sucks up everything, including gravity. What makes it so powerful? Perhaps someday we might be able to tap into that matter and the energy that comes with it.
Sounds like science fiction to me, Sourav. Okay, so we're expecting another winner to be announced tomorrow. What is that for? And tell us a bit more about it.
It's going to be the Nobel Prize for Chemistry. And the Nobel Prize for Chemistry is probably one of those prizes which we see a lot of impact in day-to-day life. Physics is mostly theoretical, as you can see here, and it takes, multiple theories and multiple experiments and trials and so many other projects to actually feel the benefit of the Nobel Prize for Physics, or a concept that has come through that. But for chemistry, it's almost simultaneous. We know that benzene, the structure for benzene came in the dream of one of the Nobel Prize winning scientists. And since then, benzene is used for everything surgical, for everything medicinal. And yeah, it's helping mankind.
Okay, Sourav, looking forward to talking to you about that tomorrow. Sourav Roy, our science reporter. Lots more on all our stories on our website, trtworld.com.